Hi, smart learners. Welcome to today's episode on logarithm. So we will be continuing with solving more equations on logarithm, and today we'll be having more complex equations to solve on logarithm. So I have like 12 questions I want to solve with you yesterday on logarithm. So the first is a wire question, like we've been solving past questions. So we have log of root 27 over log of root 81. So in this case now, we can express this root as 1 over. In indices, you know that. So we can have log of 27 to the power of 1 over 2 over log of 81 to the power of 1 over 2. So we can move this power to this side. We can also move this power to this side from our laws. So we can have 1 over 2 log 27 over 1 over 2 log 81. So 1 over 2 can cancel out 1 over 2. So I have log 27. I can easily express as 3 over 2, 3 over 3 over log 81, 3 over 4. So I can bring 3 to this side. I can as well bring 4 to this side. So I can have 3 log 3 over 4 log 3. So log 3 can cancel out log 3. So I have 3 over 4 as my answer to that simplification. All right, question 2, I have the log of root 8 all over log 4 minus log 2. All right, the same thing, I can turn this root to 1 over 2. So I have log 8 1 over 2 over log. Since this is 4 minus 2, in logarithm, whenever we have a negative sign, we want to divide. So we pick a log of the common base. You can see they are both in the same base. Since there's no base there, it means that this is in base 10, this is also in base 10. So I'm going to do 4 over 2. I'll just divide the numbers. So I can bring this to this side. So I have 1 over 2 log 2 to the power of 3. That's 8 over log over 2. So I can equally bring 3 to this side. So I have 3 over 2 log 2 over log 2. So log 2 can cancel out log 2. So I have 3 over 2 as my answer to that question. Okay. So I have question number 3. I have simplify 2 log 8 plus log 4 minus log 16 all upon log 32. All right, so here I can bring these two back to this side. So I have log 8 to the power of 2 plus log 4 minus log 16 all over log 32. Okay, so 8 to the power of 2, that's 64. So I can pick a log and see I have 64 times 4 divided by 16 all over log 32. So I can have log 64 times 4 times 1 over 16 over log 32. That's by changing this division sign into multiplication. I'm going to reciprocate the right hand side. 4 here 1, 4 here 4, 4 here 1, 4 here 64. That gives 16. So I have log 16 over log 32. So I can express log 16 as 2 to the power of 4. So I have log 2 to the power of 4 over log 32 is 2 to the power of 5. So I can do power law by bringing the powers to this side. So I have 4 log 2 over 5 log 2. So log 2 cancels out log 2. So I have 4 over 5 as my answer. Okay, so the next question is I have simplify log 3 minus log 2 all upon log 9 minus log 4. So since they have derivations, I'm going to divide. So I have log 3 divided by 2 over log 9 divided by 4. So I can write it as log 3 over 2. I can write it as also log 9 over 4. Now, you agree with me that 9 over 4 can be written as, I can write it as log 3 squared over 2 squared. So I can have log 3 over 2 over log 3 over 2 all squared. So I can bring this to the side. So I have log 3 over 2 all upon 2 log 3 over 2. So log 3 over 2 cancels out log 3 over 2. So I have 1 over 2 as my final answer. So question number 5 now. This is question number 4. Question number 5, I have simplify log cube root of 3 over log cube root of 27 squared. So I can express this as log 3 1 over 3 over log 27 2 over 3. So that I can have 1 over 3 to come to this side, I have 1 over 3 log 3 over. Then here I can have 2 over 3 comes to this side. So I have 2 over 3 log 27 is also 2 to the power of 3. Sorry, 3 to the power of 3. So 3 can equally come to this side. So I have 1 over 3 log 3 divided by 3 times 2 over 3 log 3. So log 3 here can cancel out log 3 here. So I have 1 over 3 over 3 can cancel 3 over 2. So I have 1 over 3 divided by 2, which is 1 over 3 times 1 over 2, which is 1 over 6 as my final answer. Okay, so let's move to question number 6, if I'm not mistaken. Yeah, question number 6. So we have log 3 base 4 times log 4 base 3 plus log 32 base 2. When you observe here is that we do not have them in the same basis, and even we have a multiplication sign here. So we don't have them in the same basis, and we also have a multiplication sign here. Now, the first thing to do is let's apply reciprocal law. Let's apply reciprocal law. We know if we want the base to become the number and number to become the base, we just need to bring 1 over. So if I introduce 1 over here, 1 over, I'm going to have log 4 base 3. Because I have 3, I have 4 here. So multiply by log 4 base 3. You can see. So because I can see 3 and 4, I can see 4 and 3. I know I can apply reciprocal law here. Plus log 32 base 2. So log 4 base 3 cancels out log 4 base 3. So I have 1 plus log 32 base 2. So I have 1 plus log 32 is 2 to the power of 5 base 2. This is base 2, not base 5. So 5 can come here. So I have 1 plus 5 log 2 base 2. So I have 1 plus 5 times 1. Because log 2 base 2 is 1. So I have 1 plus 5, which is 6. Okay, so let's look at question number 7. So I have evaluate log 27 base 3 plus log 3 base 9 minus log 2 base 32. So in this case now, we can actually do the powers. So let's do log of 27 is 3 to the power of 3 base 3 plus log 3. 9 is 3 to the power of 2 minus log 2. 32 is 2 to the power of 5. So I can bring 3 here, I can bring 2 here, and I can bring 5 here. But once you are bringing the power of the number, it's going to come as the number, just 3. So you have to write 3 log 3 base 3. But once you are bringing the power of the base, you are going to put a 1 over. So this 2 now will not come as ordinary 2. It has to be 1 over 2 log 3 base 3 minus this 5 also is also going to come as 1 over 5 log 2 base 2. So here I have 3 times 1 plus 1 over 2 times 1 minus 1 over 5 times 1. So I have 3 plus 1 over 2 minus 1 over 5. So let me give this a 1 so that I can find the LCM. The LCM is 10. 1 in 10, that's 10. 10 times 3, that's 30. Plus 2 in 10, 5. 5 times 1, 5. Minus 5 in 10, 2 times 1, 2. So I have 35 minus 2, that's 33 over 10. Or 3 whole number, 3 over 10. So that's our answer. Okay, so let's take it further and let's actually improve on what we have learned. Okay, so now I'll be moving into some basic equational indices whereby we have to find an unknown. So if I have log x squared, or let's start like this. If I have log p base 2 to be equals to 3, and I'm asked to find p, what I need to do is very simple. I need to introduce a log to this to the right hand side here that has 2. So I'm going to introduce log 2 base 2. Log 2 base 2 is 1, so it's just like saying 3 times 1. So we are only introducing this log 2 base 2 in order to ensure that our this solution is solvable. So I have log p base 2 to be equals to 3 log 2 base 2. Log 2 base 2 is 1, so it's just like saying we did not introduce anything at all. So I'm going to bring 3 to this side, just like we know. So I have log p base 2 to be equals to log 2 to the power of 3 base 2. Now we have log 2 to this side, I have log 2 to this side. So log 2 here can cancel out log 2 here. So I have what? P is equals to 2 to the power of 3. So P is equals to 8. But mind you, you can see that even when I have log P2 equals 3, I can just decide to pick this P and say 2 to the power of 3. And I'm still going to get my 8. So I don't even need to go through this step. P 2 to the power of 3. So base to the power of what? Of the answer. P23, P23, P23. Number base number. Number base answer. Number equals base times answer. You can also code it like this. But even with that, if you don't understand this, you can still use this method. As simple as that. So let's use that idea into solving and getting solutions to logarithm equations. All right. So I have log x squared to base 2 is equal to -6. Using our formula n equals base answer, I can say that I'm going to have my number x squared to be equals to base to the power of -6. Now let's see. We're going to have x squared is equals to 1 over 2 to the power of 6. That's from our logarithm idea. We know that already. So, but the answer is to find x, not to find x squared, because the question is going to tell you find x. We need to take the square root of this side as well as the square root of this side. So this cancels out this. So x is equals to 1 over 2 to the power of 3. So which is 1 over 8. Now let's assume that you do not know this NBA. So let's see, what can we do then? What you need to do is very simple. Log x squared base 2 is equals to -6. Take the log to base 2 of this side also. Log 2 base 2 is 1. So it's still the same thing. So bring -6 to this side. So I have log x squared base 2 is equals to log 2 -6 base 2. Log 2 can cancel out log 2. It has to be the same base. That's why we introduce 2 to this side. They have to be in the same base before they can cancel out. If they're in different base, they can't cancel out. So I have x squared is equals to 2 negative 6. You can see what we have here. Then you can finish up the solution by doing this using our indices what idea. All right, let's solve another question. Question 9. Now I have if log to base 3 x squared is equals to negative 8, find x. A 1 over 3, B 1 over 9, C 1 over 27, D 1 over 81. This is a JAM question, a UTM question, 2012 question 7, mathematics. All right, so this is very simple. You know the rule already. Number equals base to power of answer. So my number is x squared. My base is 3 raised to power negative 8. Mind you, I'm looking for x, not x squared. So I can multiply here by 1 over 2 and also multiply here by 1 over 2. You can also do that. So 2 cancels out to 2 here 1, 2 in 8, 4. So my x is equals to 3 to the power of negative 4. So my x is equals to 1 over 3 to the power of 4. My x is 1 over 81, which is option D. Yeah, 1 over 81. Let's see another question here. This is a Y question. I have log x base 9 is equals to 1.5. Find x. This is also equally simple. What you need to do here is number x is equals to base to the power of 1.5. Mind you, 1.5 can be written in the index form. So x is, sorry, in fraction, 9 15 over 10. So x is 9, 5 here 3, 5 here 2. That's 3 over 2. So what's the index form of 9? That's 3 to the power of 2 times 3 over 2. 2 cancels out 2. So I have 3 to the power of 3, which is 27. So x equals 27. X equals 27. Okay, let's take another question. I have log 16 0.25 is equals to x. Now find x. This is very simple. What you need to do is number, don't forget number 0.25 is equals to base to the power of what? Answer. 16 to the power of x. Good. So let's take this to the index form 1, 2. So I have 25 over 100 is equals to 16x. And now about 100 is 1 over 4. I have 1 over 4 is equals to 16x. Okay, so 1 over 4 is 4 to the power of negative 1, which is equals to 16x. So 4, that's the same thing as 2 to the power of negative 2, which is equals to 16. Also can be expressed as 2 to the power of 4x. So since they have the same 2, they can cancel. They have to be the same number before you can cancel out. So I can have negative 2 is equals to 4x. What I need is x, not negative, not 4x. So I have to divide it by 4, divided by 4. So x is equals to 2 here 1, 2 here 2, negative 1 over 2. That's my answer. Let's take the last question. The last question for today. I have if log 16 base 2 is equals to 4x minus 1, find x. All right, do not forget number base answer. So number is 16 is equals to base to the power of 4x minus 1. All right, what's the index of 16? That's 2 to the power of 4 is equals to 2, 4x minus 1. 2 cancels out 2, so 4 is equals to 4x minus 1. Collect like terms. 4 plus 1 is equals to 4x. 5 is equals to 4x. Divided by 4, divided by 4. So x is equals to 5 over 4. Or 1 number 1 over 4. So that brings us to the end of today's class. Expect your practice question so that you can equally improve your skill with logarithm. Logarithm is very simple question, very simple topic. So improve your skill with the task that's going to be sent after watching this video, and also be looking at substitution in logarithm as well as evaluation in logarithm. So with that, we're going to call it off on logarithm, and we can move to a different topic. So see you in the next video. Bye.